Hello. We're going to figure out how to do these things called Bohr diagrams. I'm going to show you how to create them. And this is named after a famous scientist by the name of Niels Bohr. And these were actually developed, these diagrams, so that we can have a visual, scientists can have visuals on what the atoms look like from the molecular atomic level, and it'll help to visualize what's actually going on with the parts of the atoms. So the first thing that we're going to do is we're going to draw a nucleus. If we look at the atomic number on the periodic table, that tells us how many protons. That's the identifier of the element. We take the atomic mass and we round it and then subtract the atomic number. We get the number of neutrons. And then we're going to draw these things called electron shells. So this is the nucleus. And if you think of this as like a solar system, this would be kind of like the sun. This would be like the planets orbiting around. However, you're going to see that there's going to be multiple quote-unquote planets going around. Those are the electrons. So the first electron shell can hold up to 2 electrons. It's small. It can't hold too many electrons, so it can hold 2. We're going to draw, if we need it, for some elements, one atom of an element might require more than 2 electrons to be drawn, so we're going to draw a second electron shell, which can hold up to 8 electrons. Why? Because it's a bigger shell. It can hold more. Okay, it's got a greater diameter. If the element has atoms that need it, then we have more electrons that can be placed on a third shell. And there are even more than this, but we're going to focus on up to the third. So the third electron shell holds up to 18 electrons. Now there's a catch to this. The ones that we're going to be discussing, they're not going to be holding 18 electrons. This is where the advanced chemistry really starts to come into play. However, we are going to focus on 8 electrons. So the ones that we will be working with only go up to 8. Okay. If you happen to be searching around and you look at other diagrams of other atoms and you come across one that has more than that, well, that's a special circumstance that we won't be able to get into in this course. So when you draw a Bohr diagram, there's a few simple steps. The first thing is to determine the number of protons and neutrons. Okay, and write it in a circle. So we're going to do an example. Aluminum. There's our circle. 13 protons, 14 neutrons. Step 2, determine the number of electrons. Well, if we have a neutral atom, then for every positive proton we have a negative electron to balance it out. We're going to place the electrons in the appropriate shells until they're all accounted for. So this means we've got to do a little bit of math. So the first shell holds 2 electrons. That's the symbol for electron. 1, 2. Because we only use 2, we still have some left over. So we need to start putting the other ones in the second shell. 2, 3, 4, 5, 6, 7, 8. Sometimes you're going to see these actually paired up, 2 here, 2 here, 2 on top and 2 on the bottom. This is fine though. So there goes 8. We still haven't gotten to 13, so we need a third shell. So you always want to fill up the first shell, then the second shell. You only have a third electron shell if you need it. And you can't skip. You can't put these 2 on the outside and have this one empty. It has to be filled up one first, then the other. Think of them almost like buckets. If you have a small bucket and you have more water, you need a bigger bucket to fill up. If you then have more water, you have a bigger bucket to fill up. Okay, 1, 2, 3, 4, 3 rather. Add that up, or subtract from our total, we have 0. We're all done. So what does this look like with other types of atoms from other elements? Here's hydrogen. Only 1 shell. It only needs 1 shell. Helium has 2 electrons, so therefore it fills up that first shell. Lithium, you have 1 electron on a second shell. Why? Because this one is filled up. You need that second one. Okay. If we jump down to sodium, 1, 2, see, this is the pairing I was talking about, 2, 4, 6, 8. That one's full, so therefore they would go to the next one here and fill up the third shell. Again, we won't be going anything beyond this. I want you to watch the video that I have that shows me doing one of these out by hand.